Yeah, the whole time we could have done like 3 steps of
The whole
differentiation.
frickin' time.
And we had to go through all of that just to not be sure whether this was tan y over 2 because oh yeah, the ones that reduce to 1 have 0 perimeter because those are part of the harmonic series, and the harmonic series were zeros of the original function.
Oh, I think I see. Wait, so are all those argons? Do you end up with a polynomial with 0 perimeter? A quasi-polynomial with 0 perimeter?
I mean, you probably do because, for example, for a 1/3 gon, you'd go 1, 2, 3. You just end up back at the same vertice over and over. So
Ooh.
it'd have 0 length.
Interesting. Interesting that.
Yeah.
Huh.
And then, I mean, it's pretty easy to see that if you like draw a line, there are some shapes that have the same quasi-perimeter, except the ones after.
Oh, wait, is it the same quasi-perimeter?
Yeah, because.
So, like, does this have the same quasi-perimeter as the triangle?
I don't think so, but.
Yeah.
I guess there is some.
So it's definitely a straight line, but it's not that straight line, I don't think. So let's do a quick comparison. So here,
That's not going to work.
it's officially given to us, huh? Okay, so here, I'm going to quickly draw. Here is the 3 gon. So we know what its perimeter is. So this is a length of 1. Its perimeter is going. What's the perimeter going to be again?
Actually, I don't remember it, so you can't be memorizing these things. Well, actually, it's 3√3. I'm pretty sure. Or am I wrong?
Wait, no, you're right. It's 3√3.
Okay.
3√3. Great. Perimeter of the 3 gon is 3√3. So what's the quasi-perimeter of the 3/7 gon going to be?
Well, I just take a guess and say 3√3 over 7.
Okay.
Oh, would the function say that? I mean, I wouldn't know because I don't have a calculator on.
What happens if we subtract this? Wait, let's subtract this from here.
Yes, yeah, that's probably the best course of action.
Okay, let's subtract this from this. Okay, so let's start with what happens with the y² terms.
Well, the y² terms, I'm pretty sure, perfectly cancel out.
All right, that's perfect. That's great.
So that's.
Wait, don't scratch it out.
Oh,
Just do it on another line down here.
Okay, so then that's equal to 1 to the 4th.
Over factorial. Wait,
Oh yeah, am I?
hang on. So this is minus 2y to the 4th over 4 factorial. Here's 4 plus minus. So we're subtracting from negative 2y to the 4th over 4 factorial. We're subtracting 4.
Okay, so let's write that on both sides. What do we have here? Oh yeah, minus 4y to the 4th. Also, a feeling is, I just have that gut feeling to cancel out 2 on both sides, but that's probably going to make it look less tidy.
Yeah, probably. Wait. That's a good question. I don't know. I think that's not something we'll know until we try it. But my inclination is that if we are not sure if it's going to make it better or worse, I think we leave it as is because it will be much easier to do it later down the line than it will be to realize it's making things messy and undo it.
Yeah, that's. If it might cause problems, don't do it. So let me just bring all of this to that side.
I do it the other way around.
Oh, okay. So
Just because of how the signs will work.
it's great migration to 2y to the 4. Oh yeah, you end up with a positive.
It'd be 4 over 4 factorial. Because you're just
I'm
adding.
blind. I looked at this first, and then for the denominator, I looked
Oh.
at it. Oh my gosh. Then I think the difference here would be, minus 4y to the 6 over 6 factorial plus 6y to the 8th over 8 factorial, which does give an interesting pattern. It almost looks like what we saw. Oh yeah, it's the same thing as what we saw earlier with an extra factor of y squared. I'm pretty sure. Y squared over.
Wait,
no, it's not. It's not. It can't be.
wait a second.
That's not right because of.
Ooh, this is interesting. But I do agree that there's that weird common factor of 2y squared.
Y squared.
That seems to be.
I don't know why that happens, but it happens.
Oh, yeah.
I mean, both of these have a common factor of y squared, so we could have expected it. But this one actually has a common factor of y to the 4th.
Yep. Very interesting. Is that something we should have expected?
That could be. Okay.
Actually, I think right now, I haven't delved into this enough to say that it should make sense. So I'm just gonna say that it's surprising.
Yeah. Okay, this might be too bold of a move to do, but what if we factored this out?
I'll be honest. My inclination is towards making it factoring out just y squared.
All right. So then.
Basically, so that we have a nice we have like 2y squared minus 4y to the 4th.
2y squared over 4 factorial. But the problem is these denominators, because you would think that like 6 factorial plus 4 factorial over 4 factorial plus 2 factorial is equal to something like this, but
Ooh, no. Nope.
yeah, unfortunately that is definitely not true. So you can't have that sort of relation between those two. Unless you really tried hard and stretched your definitions, I don't think you could have that sort of relation.